Hello everyone, welcome to the channel. So today's topic is class 8, a square and a cube. This video is completely based on the new textbook and this is a one-shot video where I'll be completing the whole chapter in just one take. So let's get started. So firstly, we will learn about a square. What is a square? So this is a square, isn't it? So as we know square, all the sides are equal. So if I take this as 5, this is also 5. So if I want to find area of square, what is area of square? 5 square, which is 5 into 5, 25. So square numbers are nothing but when you have 2 on the top. 5 square, it's a square number. 2 square, 4. 3 square, 9. So these are all square numbers. 25, 4, 9. These are all square numbers. Now when I talk about perfect squares are nothing but the number that is obtained by multiplying two same numbers. For example, 2 square. 2 into 2. Same number multiplied 2 times. Whatever result you get, that is a perfect square. So 4 is a perfect square. Similarly, 3 square, 9 is a perfect square. 4 square, 16 is a perfect square. So 4, 9, 16, 25, 36, and so on. These are all perfect squares. So how do I get that it is a perfect square? When the same number is multiplied by itself. The answer that you get is a perfect square. I hope this is clear. All right, now next, moving on, what are negative numbers? Negative number. So if I take minus 6 and if I want to square this number, okay, when I want to square a negative number, what do I get? Minus 6 into minus 6, which is 6 into 6, 36, minus into minus plus. So we are getting a positive number. Similarly, one more example, minus 5 square. Again, you get plus 25. So whenever you have a negative number, whenever you are finding the square of a negative number, the result is always positive. You need to know this. The result is always positive. So, in short, I would tell you that if the power is an even number, let's say 2, power 4, power 6, power 8, if the power is even, the negative becomes positive. All right? Okay, moving on. Now, what is the pattern here? Here I have written 1 to 30 squares of all the numbers. So, I am not telling you that you need to know this, but if you know them, well and good. But even if you don't know, by practicing, these squares will stay in your head. So, not a problem. So, let's see what is the pattern that we see here. So, when a number is ending in 1, the square of its number also ends in 1. Number ending in 2, the square ends in 4. Number ending in 3, the square ends in 9. Number ending in 4, the square ends in 6. See, the units digit is 6. Now, number ending in 5, the square ends in 5. Number ending in 6, the square of that number ends in 6. So, whenever you have any number that ends in 6 or 4, the square also ends in 6. Now, number ending in 7, the square ends in 9. So, 3 or 7, when the number ends in 3 or 7, its square ends in 9. Now, number ending in 8, the square ends in 4. Number ending in 9, the square ends in 1. And if the number is ending in 0, definitely you will have 0. Okay, so here you need to understand. I don't want you to mug up. I'll tell you how to remember. So any double digit, triple digit, whatever number you take, you just need to see now 27. Okay, let's take 37. It's not the year. I need to find the last digit, the units digit of the square. So what is the number ending here? 7. So when number ending in 7, what is the unit digit? It is 9. That is fine. The other way, if you don't remember this pattern, you can always do it on the spot. How? 7 square is 49. Yes. So think, what is the square of the last digit? 49. Now, what is the last digit here? 9. So this is it. So it is very easy to find the last digit of any given number. All right. Now I want to find the last digit of the square 74. Now 4, 4 square, if I think 4 square is 16. Now in 16, what is the last digit? 6. So my answer is 6. And if you can remember the pattern here, we can see that when a number ends in 4, its square ends in 6. I hope this is clear. If you remember the pattern, well and good. Even if you don't remember, no problem. You can work it out immediately. Next, coming up, we have perfect square and odd number. Now we will see what is the, relation between a perfect square and an odd number. So let me take 1. 1 is 1, okay. Now I'm taking 1 and I'm adding another odd number. So you know odd numbers are 1, 3, 5, 7, 9, and so on. So 1 plus 3 makes 4. Now I'm doing 1 plus 3 and I'm adding a new odd number which is 5, which gives me sum as 9. Next, same 1 plus 3 plus 5, and now I'm adding the next odd number which is 7. So I get 16. Yes, one more. 1 plus 3 plus 5 plus 7, next odd number is 9, and the sum comes up to be 25. So if I say this is 1 square, this is 2 square, this is 3 square, this is 4 square, and this is 5 square. So when you are adding sum of consecutive odd number, consecutive means one after the other. When you're adding sum of consecutive odd number, you end up having a perfect square. You end up having a perfect square. Now here we can see you have one odd number, it is 1 square. Two odd numbers, 2 square. Three odd numbers, 3 square. So it is very easy. You just need to see how many odd numbers are there. That's square. If I have 10 odd numbers, that answer will be 10 square. If I have 13 odd numbers, consecutive sum of 13 odd numbers, so 13 square, which is 169. This is the relation between a perfect square and an odd number. All right. Now, triangular numbers. What are triangular numbers? So, firstly, let us see what are square numbers. This is 1 square. Now, this is a square. You have 4 dots. Now, you have, square, all the sides are equal. 3, 3, 3, 3. You have 9 dots. Now, you have 4 rows, 4 columns make 1 row, so it is 16. So these are all square numbers, isn't it? 1 to 4, 2 square, 3 square, and 4 square. These are all square numbers. Now, what are these triangular numbers? So triangular numbers will definitely be in triangle shape. Okay, so starting with 1, this is 1. Now, you have 1 and 2 more dots have added. So you can see a triangle is formed, isn't it? 3. 3 dots. Next, 1, you have 2 dots, and now you have one more column with 3 dots. So, how many dots? 3 plus 2, 5 plus 1, 6 dots. Then 1, 2, then third column. Now, fourth column will have 4 dots. So, how many will we get here? 1, 3, 6, and then 8. No, 10. Similarly, 2 dots, then 3 dots, then 4 dots, now 5 dots. So when I add them up, I get 15. So these are triangular numbers. Now, if I find the sum of these, 1 plus 3, 4, 3 plus 6, 9, 6 plus 10, 16, 10 plus 15, 25. Now, what are these? These end up to be a square number. Yes, these are triangular numbers. So when you add two triangular numbers, you obtain a perfect square. All right. Next, coming to this one, let us see some questions. These kind of questions generally come for a mark. If a number has two zeros, its square will end with how many zeros? Okay, a number has two zeros, that means 100. So its square, how many zeros will it have? 1, 2, and double of 2, 4 zeros. So if a number has 3 zeros, it will have 6 zeros. If a number has 4 zeros, the square will have 8 zeros. So double. Okay. Next, very important. Okay, this one. The sum of first 15 odd numbers is 2 to 5. The sum of first 15, 1 plus 3 plus 5 plus so on till 15th odd number. The sum is 225. Find the square of 16. You need to find the square of 16 by finding the 16th odd number. Now see, it's a time waste. If I want to write all the 16 odd numbers, I will take some time, isn't it? So what I'll do is you have a separate formula to find the odd number. So that formula is 2n minus 1. So this formula gives you whatever odd number you're looking for. Now, for example, if I want to find second odd number, so n is 2, 2 into 2 minus 1, 4 minus 1, which is 3. See, if n is 5, 2 into 5 minus 1, 10 minus 1 is 9. See, this is the fifth odd number. Similarly, I want to find the 16th odd number. So n will be 16. So 2 into 16 minus 1, which is 31. So 16th odd number is 31. Now, how do I find my 16th square? Using odd number formula. Now, as you know, to find 16 squares, you need 16 odd numbers, isn't it? So till 15 odd numbers, the result is 2 to 5. Till 15 odd numbers, the result is 2 to 5. Plus the 16th odd number, we just found it, 31. So I get 256. So this is nothing but 16 square. So whatever square I need to find, I need to add all the consecutive those many odd numbers. So if I want to find 16 square, I will add first 16 odd numbers. So till 15, we already have the result. So 15 plus 16th odd number will give you 16 square. Very important. This formula is really helpful. I hope this is clear to everyone. Next one. Now, what is square root? 2 square will be 4, isn't it? Now, 4 square root is 2. 4 square root is 6. 2. Similarly, 3 ka square is 9. But 9 square root is 3. Now, so basically the symbol for square root is this one. And if I want to find 36, so I'm going to think what is that number which when multiplied by itself gives you 36. So 6 is the number. So basically 6 is the square root of 36. So a number multiplied by itself gives the square. Yes. And the reverse is nothing but the square root. I hope everyone is clear with the square root concept. All right, now next, how to find the square root? You have three methods to find the square root. First one is hit and try. We are going to explore each and everything. Next one is subtraction method. And the last and mostly used is prime factorization. These are the three methods that we use to find square root. First one, let us explore the first one, which is hit and try. Now, hit and try, let's see. 10 square is 100. 20 square, 2 square is 4, followed by two zeros. 30 square, 3 square is 9, followed by two zeros, and so on. Now let us see 576. Now 576 falls between 400 to 900, isn't it? Between 20 square and 30 square. Yes. Now let us see what is your ones digit. 6. So what is that number which when you square you get 6? Either it can be 4 or 6. So when a number ending in 4 or 6, its square will give you 6 as the ones digit. So the options can be 24 or 26. Yes or no? We clearly know that the number lies between 20 and 30. So ending digit can be 4 or 6, 24 or 26. Now which one is it? Now 576, is it closer to 400 or 900? It's closer to 400. So it should be 24. So root of 576 is nothing but 24. All right. Now let's see the next one. Firstly, we will see the ones digit. It is 7. So it is not a perfect square because we know that when a number ends in 2, 3, 7 or 8, it is never a perfect square. So see the ones digit. If it has 2, 3, 7 or 8, do not waste your time. You can directly write not a perfect square. Else, you can follow this hit and try method. All right, is everyone clear? Now, next method is subtraction method. So here we use consecutive odd numbers and we subtract them from the result. So 121, first odd number is 1. So I get 120. Now 120 subtracted by next odd number 117. 117 subtracted by next one 112. 112 subtracted by 7 105. 105 minus 9 will be 96. 96 minus 11 will be 85. 85 minus 13 will be 72. 72 minus after 13 it's 15. It is going to be 57. 57 minus 70 is 40. 40 minus 19 is 21 and 21 minus 21 is 0. So if you end up having a 0, that means it is a perfect square. If you get a 0, it's a perfect square. Now, what is the square root of this? So how many odd numbers have we subtracted? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 odd numbers. So the square root of 121 is 11. Simple. But this method is generally used when you have smaller numbers. Because when you have bigger numbers, it will take so long to, do the subtraction and it is not advisable. All right. But when you have smaller numbers, only then it will be asked. So nothing to worry. Now the next method is the most often used prime factorization. So as you know, the number itself tells prime numbers. So we will only use prime numbers. So it is just that how do we find LCM? The same method we will be applying here. So 2 ones are 2, 2 six are 2s are 281s are 327, 39, 3 threes, 3 ones are. So since you are finding square root, you will make every number into pairs of 2. 2 square, 3 square, and then 3 square. So I can club them and write 2 into 3 whole square. The square and the root gets cancelled. 3 into 3, 9. 9 into 2, 18. So the square root of 324 is 18. Or I would rather say the square of 18 gives you 324. All right, next one. Let us do one more question. 1936. Let's do using prime factorization. To 9's 18, to 6 12, to 8 16, to 4's are 8, to 8's are 16, to 4's are to 2 4 2, 1 2 1. And then 11 elevens are 11 ones are. Again, make them into pairs. 2 has its pair, another 2 has its pair, and 11 has its pair. So if every number has its pair, only then it is a perfect square. Only then you can tell it's a perfect square, else it is not. So the square and root gets cancelled. 2 into 2, 4, 4 into 11, 44. So the square of 44 is 1936, and the root of 1936 is 44. Now this is one very very important question. You get this question in your exam generally. Find the smallest number by which 9408 must be multiplied so that the product is a perfect square. So for now, 9408 is not a perfect square. You need to find a number which when multiplied by this becomes a perfect square. All right. So first we'll find the prime factors for it. Let us do 2 fours are 8, 2 sevens are, 2 fours are, again 2 twos are 4, 2 ones are, 2 sevens are 14, 6 are 12, 2 fives are, 8s are, 2 fours are 8, 9s are 18, 2 fours are 8, 2 twos are, 2 fours are, 2 sevens are. Now, okay, 2 fours are 8, sevens are, 2 twos are 4, 2 threes are 6, 2 fives, 2 ones are, 2 sevens are 14, 2 six are, 2 fives are 10, 2 eights are 16, 2 twos, 2. Okay, here I went wrong, I guess. 2 twos are 4, 2 nines are 18, 2 fours are 8, 2 ones are, 2 fours are 8, 2 sevens are 14, 7 21s are, 7 threes are, and 3 ones are. So now let us see the pairs. You have 2 square, you have 2 square, you have 3 pairs of 2 square, you have 1 pair of 7 square, and 3 is left. 3 doesn't have its pair. So when a number doesn't have its pair, it is not a perfect square. Now, what is the smallest number that I need to multiply so that it becomes a perfect square? So the smallest number that needs to be multiplied is 3. Okay. So once I multiply this number with 3, what do I get? 2 square, 2 square, 2 square, 7 square, and 3 square. Now look, every number has its pair, so definitely it's a perfect square. You also need to find the square root of this one. So 2 into 2 into 2 into 7 into 3 whole square. Square and root gets cancelled. 2 twos are 4, 4 twos are 8, 8 threes are 24, 24 into 7, 168 is the square root of the final product. I hope everyone is clear with this. Very, very important. Now, square root of a perfect square can be negative, true or false. Okay, so let me take any perfect square, 36. Now, square root. See, whenever I take a square root, it will always take positive and negative values. So, the square root can be plus 6 or minus 6. So, the statement is true. Very, very important. Please take a note of it. The square root of any perfect square can be negative. It is positive and negative. Next one, cubic numbers. So we have just seen what are squares, 2 into 2, which is 2 square 4. Now similarly, cube is nothing but it has 2 into 2 into 2. It has three dimensions, length, breadth, and height. So which is 2 cube, which is 8. All right, these are nothing but cubic numbers. Any doubts still here? Next one. Now let us see the pattern for cubic numbers. We have already explored the square numbers. Let's see the cube numbers. So any number ending in 1, the cube also ends in 1. Ending in 2, its cube ends in 8. Ending with 3, its cube ends in 7. Ending in 4, its cubes end in 4. Ending in 5, cubes also ends in 5. Ending in 6, cubes also ends in 6. Ending in 7, cube ends in 3. Ending in 8, cubes ends in 2. Ending in 9, cubes ends in 9. 0, 0. So I see 1, 4, 5, 6, not 8, 1, 4, 5, 6, 9, 10. They end in the same number. Yes, but 2 ends in 8 and vice versa. 8 ends in 2. Similarly, 3 ka cube ends in 7, whereas 7 ka cube ends in 3. So you only need to focus on this pattern. Rest all it ends in the same number as the number is. Okay. And number 2, the cube ends in 8. And number 8, the cube ends in 2. Same. And number 3, the cube ends in 7. And n number 7, the cube ends in 3. All right, you need to know this. We will be using this. Now, negative number. Negative number, what is the cube of a negative number? So I have already seen the square of a negative number is always positive. See, minus 6 into minus 6, 6 into 6, 36, minus into minus plus. So the negative square is always positive. But when coming to cubes, minus 6 cube, which is minus 6 into minus 6 into minus 6. 6 into 6, 36. 36 into 6 is 216. But what about the sign? Minus into minus plus, plus into minus minus. So the negative numbers cube is always negative. Negative numbers cube is always negative. Very, very important. I hope everyone is clear. Yes. Now, moving on, we have the next question, the next part as taxi cab driver. Now, taxi cab driver is just a name. It's nothing like it's related to taxi and cab. Okay. So numbers that can be expressed as the sum of two cubes, as the sum of two cubes in two different ways. Now, for example, 1729. 1 cube plus 12 cube. So when I add the answers, I get 1729. Similarly, 9 cube plus 10 cube, 1000. So when I'm adding this, I'm getting 1729. So these are taxi cab drivers. So a particular number can be expressed as a cubes of two numbers in two different ways. All right, so these are some of the examples. And now the smallest number that can be written as the sum of two cubes in the two ways. So this is for your homework. Please drop your answers in the comment. So I'm going to respond. So you can just create a table, like you can write 1 to 30 cubes and see what is possible. If you have the table in front of you, it will be easier and quicker. Next up, we have perfect cube and odd number. So I have already shown you the relationship between perfect square and odd number. Now it's perfect cube. So in perfect cube, 1 is 1. Okay. Next odd numbers, 3 plus 5, which is 8. I'm not taking the same number. Every step I will take different odd numbers. Now next 7 plus 9 plus 11 is 27. Next odd number 13 plus 15 plus 17 plus 19 is 64. So every time we are taking different odd numbers. So this is basically 1 cube. Now 2 odd numbers, 2 cube gives you 8. 3 odd numbers, 3 cube gives you 27. 4 odd numbers, 4 cube gives you 64. So basically when it is about cubes, You will just count how many odd numbers are there. Its particular cube is the sum. Now let's see this question. How many odd numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 odd number. So it is going to be 10 cube. It is the cube of 10, which is 1000. So when I add all these numbers, the end result will be 1000. I hope everyone is clear with this relation. Okay. Now let us explore the cube. See, 10 cube is 1000. If I take 100 cube, you will add 3 times 2 zeros. 1, 2, 3, 4, 5, 6. If I take 1000 cube, you will add 3 zeros 3 times because it is cube. 1, 2, 3, 1, 2, 3, 1, 2, 3. So if you see the pattern, 3 zeros, 6 zeros, and 9 zeros. So what are these numbers? These are multiples of 3. So whenever you have any question with respect to zeros, if it is a perfect cube, all that sort, then you see if it has multiples of 3 zeros, if it has 3 zeros, 6 zeros, 9 zeros, 12 zeros, 15 zeros, then yes, it is a perfect cube. But it doesn't. But if it doesn't have these zeros, then it is not a perfect cube. You cannot waste the time there. All right. Let's go. Next, cube root. See, one method is you can always, do prime factorization. That is one method. The other method I'll tell. Okay, this one let me help you with prime factorization. 3375, 5 6 are 30, 5 7s are 35, 5s are. 5 1s are, 5 3s are 35. 5 2s are 10 and 7s are. 3 9s are, 3 3s are, 3 1s are. Now you know cube root symbol is like this. So here, since we are doing cube root, in square root we made them into pairs of 2. But in cube root you'll make them into pairs of 3. So this is one pair, 5 cube, and this is another pair, 3 cube. So I can write 5 into 3 whole cube. The cube and cube root gets cancelled and your answer is 15. So the cube root of 3375 is 15. Or I can also tell cube of 15 is 3375. Okay. Now is this a perfect cube? It has two zeros. What did we see? If you have zeros like 3 zeros, 6 zeros, 9 zeros, if your zeros are multiples of 3, only then it's a perfect cube we just saw. So it is not a perfect cube. Next, this is one important question and it is very, very easy. You are told that 1331 is a perfect cube. Okay. Can you guess without factorization? Without factorization as in without prime factorization. What is cube root is? Now let's see this. 1331. Now as we know 10 cube is 1000, 20 cube is 2 cube is 8, 8000, 30 cube is 27,000 and so on. All right. 40 cube is 64,000. Okay. Now 1331 lies between 10 and 20. Yes. It lies between 1000 and 8000, 10 and 20. Okay. Now what is the ones digit here? 1. So we have seen the pattern. A number ending in 1. Its cube also ends in 1, isn't it? So here the ones digit should be 1. And since it is lying between 10 to 20, it is going to be 11. So easy. Let us see one more question. 4913. Now this lies between again 1000 and 8000, which is 10 cube to 20 cube. Okay. Now, what is the ones digit here? 3. So we have seen if a number ends in 3, its cubes ends in 7. Yes. So one's digit is 7 and ten's digit should be 1 because it lies between 10 and 20. So easy. So the cube root of 4913 is 17. So without solving also we can do it using the pattern that we have learned. All right, let's do one more. 12167. Now this lies between 8,000 to 27,000, which is 20 cube to 30 cube. Yes? Okay. Let's see the ones digit 7. So when do you get 7? When do you get 7? When a number, when a number ends in 3, its cube ends in 7. Yes? So when a number ends in 7, its cube ends in 3. So we have already seen this 8 and 2 are related, 3 and 7 are related. Yes? So this will definitely have 3 in the ones digit. So it lies between 20 and 30. So the cube root will be 23. One more, last one, 32,768. Now this clearly lies between 30 cube and 40 cube. Yes, it lies between 27,000 to 64,000. All right. Now what is the last digit here? 2, 8. So when a number ends in 8, its cube root ends in 2. So your last digit should be 2. And so here it should be 3 because it lies between 30 to 40. So the cube root of this is 32. I hope everyone is clear and it's so easy. Yes? All right. One last topic for this chapter, successive differences. Now, what is this successive differences? Now, let us take square numbers. Okay, square numbers. What are the square numbers? 1, 4, 9, 16, 25. Let us find the difference. 3, 6, um, sorry, 9 minus 4 is 5, then 7, and then 9. Now, what are the differences again? 2, 2, 2. So, what I'm trying to show is for the square numbers, when you keep on finding the differences, at one level, all the differences will come out to be the same. You know, at one level, all the differences will come out to be the same. Same with the cube numbers. What are the cube numbers? 1, 8, 27, 64. Yes, these are the cube numbers. Let's take one more, 125. What is the difference here? 7. What is the difference here? 19, 37, and 61. Let's find again. The difference here is 12, 18, 24. See, not necessary that at level 2 your differences will be same. It can take multiple levels, but at one level all the differences will be same. Now let's do it again. 6 and 60. At one level the differences comes out to be the same. This happens with the square numbers and cube numbers. So here we end the topic. So this is a complete video on a square and a cube chapter of your textbook, Ganita Prakash, new version. All right. So for more videos, for more chapters, please subscribe to the channel and see you in the next video. Bye. Thank you.